Okay, in previous part we developed this simple application that is a Node.js HTTP server running on port 3000. We tested it and we also created a Docker file to build a base image with all the necessary dependencies like Node.js and npm. We copied our application to inside image, and also we specify a command to run when we start a new container. We tested our image and also we pushed it to Docker Hub, a place on the internet that hosts public images, and not only public, it can host private ones as well. Well, in this part I wanna mention this feature of Docker called Docker service that allows us to create services and do basic operations with it, like scaling, inspecting. What services? Well, the service is an entity that describes how many replicas of a container you want to run, and service will keep up with these requirements and for you, and it will manage containers automatically. Let's say that in previous part we were managing containers ourselves because we created a single copy of container with docker run command. In this part we won't need it. We'll just say to our service how many versions we want, how many replicas we want, and Docker service, also known as Docker Swarm mode, will run for us and will actually manage all the problems that might happen, like if our container died or killed for some reason. Docker Swarm will respawn this replica to keep the requirements equal to actual state of our cluster of containers. So this is about what Docker Swarm is, and there are several commands. Well, first of all, you need to initialize and switch to swarm mode. Yeah, and several more principles about swarm mode. This is one example of orchestration system, and by orchestration system I mean the following. It's really applied only to production, and you don't need to think about it while you're developing your application. But for production you might have a picture like that. You have a lot of clients, right? And all of them tries to access your application. Clients and you have one running copy of your application, and this could be a problem because you might end up having a lot of requests coming to your application, and it will fail application in some scenario, overwhelm it. And the way you solve it by creating multiple copies of your application, and this is the simplest way because you don't need to change anything inside your source code. The code stays as it is. You just provide more instances of your application. This way you limit the amount of traffic that each individual application might receive, and this is a basic way to scale your application. And you do it by different approaches, and one of these approaches is to have an orchestration system like Docker Swarm manages that will manage state that you want for a system. Let's say and you do it by specifying what kind of configuration you want to have. Like you have 3 replicas in this case, and there are several more options, and there are other options. There are other systems similar to Swarm, Docker Swarm. The popular one being Kubernetes, that does a similar things. Docker Swarm, as some said, is a little bit easier to start with, and it actually provided by Docker by default. So you install Docker, you already have a Swarm mode capability. You just need to switch to Swarm mode and start using it. So this is about what orchestration and services means. Now let's jump to commands and try to create something. So you initialize the Swarm mode with Docker Swarm init, and I think that and his output. It says that Swarm initialized, and we are on the current node, and our node is a manager. To add a worker to this Swarm, run the following command. So what is a manager and what is a worker node? And what is a node? A node is basically a reference to a server. You see, when you have several copies of your application, it might run on a single machine, right? Like a local host, or it could be several machines because of resource limitation. And you don't see, and Docker Swarm will hide these interactions from you. For you, it won't matter how many nodes are in your cluster. You might have 3 of them, might have only a single one, and basically cluster starts from a manager node. This is the first node that is responsible for all the interactions and for scheduling, etc. This is a manager node, and you create a manager node with Docker Swarm init command, and our current computer is a manager now. And then you might, if you feel resource limitation, you might create several more. You might get several more servers and connect them to the master node. With this command, it specifies access token for the worker that identifies a worker, and this command also contains IP address with which your worker node can access a master on specific port. And by joining this cluster, these computers become workers, worker, and all the following interactions, like when to run your replicas, is handled by Docker itself. And it will, in general case, it will try to balance running containers between workers, and if some container dies or some worker dies, a manager will see it and will redirect containers to another place. And this is the difference between manager and a worker. For now, we won't have any worker because without workers, you don't need to create the servers to acquire them from somewhere. It's easier for this video, but you don't see any difference. You won't see any difference if we have one, because all these interactions are hidden by a manager, node, and you'll have the same behavior if you have 100 workers for today, or 0, 1, because manager as well as worker can run containers by itself. So this is about these commands and difference between manager and worker. So now we have swarm mode switched on, and now we can run different commands with Docker service base command, and there are several of them, like ps. But we need to provide a service name here. First let's create our service, and when creating a service we need to specify replicas, how many copies of our application we want to run. Let's stick with 1 for now, and the name of our service, let's say that we have application service that will run application app, our app image, and we provide image name at the last argument app, and we can provide a tag here, but we have latest by default. It will pull latest version of our application by default. So we press enter, and after several seconds it should start creating our service, and it has one task by default, and now it's trying to verify that our application is running, and configuration is applied here. So now if we type another command to inspect services, we'll see a single service with replica counts and a version of application. So now what? Now we can also, to get more details on the service, we might run inspect and provide the name of our service. It will give us different options. Most of them is useless for now. Resources, as you can see, we can manage limitation factors for our services, how much memory service could, not a service but a container could use, and different options here. So now we have our application running as a single replica. Now let's try to remove a service. There is a command to remove it with git docker service remove app service. It will remove service, and we can scale our service with docker service scale, and we provide a service name, and then how many a new configuration for how many services replicas we want to run. In this case we want to run 3 replicas. It will verify all of them, and now if we type git service, here's our updated service, and if we inspect docker ps, it will show us all our running replicas here. But if in case we had several workers, we won't see all of them. We won't see all of replicas here, because some of them will run on different workers. And if you SSH into a worker and run docker ps, you'll see some of these replicas over there. So here this is about scaling it, and you might scale up and scale down your replica count. And also with docker service update command, you might change image of your service For example, let's say we want to run Nginx service, Nginx image, latest. Let's stick with Nginx and provide a service name, and this way it will update all the containers. Here, as you can see, we run up latest, right? And it will probably take some time to pull an image, and I won't wait for it, right? Yeah, it's gonna take some time because I don't have Nginx latest image installed pulled already. So it says that operation continues in background. Let it continue in background. Let's inspect what it does. Replicate it, and we can inspect our. Let's try to see what is it doing right now with Docker service ps preparing. Okay, it says that it's preparing our service, and namely it tries to download latest version of Nginx from Docker Hub, and then after it, okay, now I think that it's actually running right now. So if we type ls, we have one replication, and okay, this is about updating. But what about publishing? And what about load balancing? Because all the traffic that comes to a manager or to actually any other worker, because it doesn't matter if traffic comes to a worker, there is a feature that will abstract all the nodes, and it will allow clients to basically call any of the nodes, and traffic will be forwarded to a specific container, to a specific node. So Docker Swarm handles these interactions as well. But now our service is hidden from the outside network. It only is available inside the swarm, and we won't be able to access it. To actually access it, we need to publish our service, and we do publishing with a simple service update publish add command, and we specify what port we want to use as outside port. In our case, let's go with 8080, and what port inside container we want this port to be bind to. And because we have Nginx image running in our containers, in our replicas, it has Nginx by default has 80 port, serving some content in it. So we'll be able to inspect is everything working correctly by binding it to some of our ports. Then we provide a name, app service, and that should be it. It will update the configuration, will update all the replicas, and we'll probably be able to inspect it with curl, for instance, curl HTTP and our 8080 port, and here's our Nginx Nginx file served from the container. And now we have actually one replica, and yeah, and maybe it will work the same way if we change a replica count to anything else. And here's our configuration for port binding. So you might have as many services as you want on your local machine, and if you want to publish your service when you create it, it will be a little bit different. When you create a service, you'll specify publish option instead of publish ad, and basic options like replicas goes here as well. So let's remove our service, and to clean up the system from any services, any swarm related features running, you do it with git service rm, the name of the service, or you might as well provide you might as well remove all the services with, you see we have this flag -q that will return a list of IDs, and you can do something like that to actually follow the output of this command to anything to any other commands, and you this way you can remove the list of services that you specify, and this way all the services currently running will be removed. So Docker service ls won't show us anything here, and also Docker ps won't show us anything here as well. And the last step is to remove a swarm, and you do it with leave command, docker swarm leave, and here's an error. It says that you're trying to leave at the last node, and this node is a manager, so you need to specify a force option to actually remove to forget any states of your swarm. So we specify a force option, and now our swarm is removed. So basically this is it about Docker Swarm that I want to mention, and yeah, this is a more in-depth topic, and I mentioned it very quickly today, and maybe I won't maybe I will return to the topic of Docker Swarm and Kubernetes in the future, but for now this is necessary information to follow along with other videos, because sometimes I will reference Docker Swarm in the videos. So that's it for today.